So today I want to just show you some different acids, common acids that you would have had contact with a lot of these, and bases, and then talking about how we can calculate the pH of acids and strong acids and bases. Okay, so first of all, acetic acid is what is in vinegar. So if you like pickles, or if you like Italian salad dressing, or many other types of anything pickled for sure, then you've had vinegar and you've had acetic acid. And a lot of also people use vinegar as a cleaner because it's good for killing germs. Hydrochloric acid, another type of acid, that's in our stomach, and it is also what we use in pools, swimming pools. It's used in fertilizers and dyes, and as it says here, electroplating, photography, textile, rubber industries to clean metals. It's commonly called muriatic acid, and again, you can buy that to help keep your pools clean because it is poisonous and it does kill bacteria in our stomach. That's what helps us digest our food. And the reason it doesn't eat through our stomach is because your stomach has a mucus lining that keeps the acid inside of there. But sometimes if you are sick and throwing up and you have really nothing on your stomach and you're just kind of throwing up that stomach acid, it's burning. Or sometimes you have acid reflux because you do have a fairly strong acid in your stomach. It's about 1 molar. And another acid is carbonic acid, and we can find that in caves. The stalagmites and the stalactite formation is from carbonic acid. It's also in carbonated drinks like our Coke and Mountain Dew and whatever kind of carbonated drink you like. Phosphoric acid, that's in detergents and fertilizers, and it is also in soft drinks. It's slightly sour but has a pleasant taste. Sulfuric acid, that's what's in car batteries, and it's also used to manufacture fertilizer, other chemicals. It's a dehydrating agent. It causes burns by removing water from cells. So there's concentrated sulfuric acid in car batteries, which is why you never just want to, one of the reasons that you never want to throw a car battery just in the trash. A lot of times too, there's lead and other harmful things in car batteries, so you should not just throw them in the trash. So if you get acid on you, if it's a strong acid, you can get a burn like this. That's why I always tell you, if you get the hydrochloric acid or sulfuric acid or nitric acid that we've used in lab, if you get that on your hand, you need to wash it off immediately, because if you let it sit, you get a burn like this. This foot down here, it's kind of gross, but it's very gross actually. This would be like if it was sitting there for a long time with strong acid on it. It can eat through the skin and get down to through the muscle and all that, but that would take a bit. If you immediately wash it off, you're not going to, it's not going to be that bad. But again, acids can burn you. Bases, on the other hand, there is sodium hydroxide, which is probably one of the most common strong bases. It's used in the manufacture of soap. It's used to make medicines and paper, and it's used to make rayon, and it's also what's in drain cleaner and oven cleaner. So sodium hydroxide is a strong base. Calcium hydroxide, also known as slaked lime. If you have seen farmer fields where it's all white, then I'm sure that they have put the lime on there to a lot of times the soil gets too acidic for plants as different crops have grown and used a lot of the nutrients out of the soil in that. So they will put lime on there to neutralize the soil. It's also used to neutralize acid in water supplies and the manufacture of bleaching powder, a dressing for acid burns, antidote for food poisoning, and fungicides, and it's in whitewash. It's also mixed with sand and water to make mortar, which is used in the construction of buildings. So it is very has a lot of uses. And again, here it says it's used by farmers on fields to neutralize the harmful effects of acid rain. Ammonium hydroxide, or ammonia, that's used to remove ink spots from clothes, to remove grease from window panes. That's what's in like Windex, and it also is in other cleaners, that ammonia smell. And it's used in cosmetics. Alkalis are alkaline batteries like LiOH, KOH. Those are bases that are used in alkaline batteries. And you can get burned by strong bases just like acids. They react with the fat and protein in your cells. So you also don't want to mess around with the strong bases. You don't want to get Drano or any of those strong bases on your skin and let them sit. You want to wash them off immediately. So there's 6 strong acids: HCl, HNO3, HBr, H2SO4, HI, and HClO4. Those are the 6 strong acids. All other acids are weak acids. When we're calculating pH, however, we're in honors, we're only going to do the pH of strong acids. And same thing for strong bases. We're only going to calculate the pH of the strong bases. And those would be the alkali metals with OH minus. So that's LiOH, NaOH, KOH, RbOH, and CSOH. And the larger alkaline earth metals with hydroxide, CaOH2, SrOH2, BaOH2. So those need the 2 OHs because they're all +2. So those are your strong bases, and those are your strong acids. And strong acids and bases completely dissociate into ions in water. So that means we can determine the concentration of the H3O plus and the OH minus from the concentration of the acid or base. So we've already talked about that acids produce H plus or H3O plus in water, and bases produce OH minus in water. So if we know the concentration of the acid, we look at what it breaks up into, and we can see. So HCl, being a strong acid, completely breaks apart. So if the acid is 1 molar, then the H plus or H3O plus concentration is also 1 molar. And then so is the Cl minus, but we don't care about that for pH. Okay, so for pH, we need to know the H plus or H3O plus concentration. So this acid has 1 H in it, and so that H comes off completely because it's a strong acid. So if this is 1 molar, this is 1 molar. Same thing for strong bases. Strong bases completely break apart into ions, dissociate in water. So NaOH splits up, it's a 1-to-1 ratio. So you get, if it's 0.1 molar NaOH, then you get 0.1 molar Na out of it, and you get 0.1 molar OH minus out of it. So from 0.1 molar NaOH, you get 0.1 molar OH minus. Again, for pH, all we care about is either the H plus, H3O plus, or the OH minus concentrations. So it's a 1-to-1 ratio when there's 1 OH and when there's 1 H. With the base like calcium hydroxide, though, there's 2 OHs. So when calcium hydroxide breaks up in water, the calcium ion is 1-to-1, so it's 0.1 molar if this is 0.1 molar. But now you're getting 2 OHs out of it. So that means the OH minus concentration is double. It's 0.2 molar when the calcium hydroxide is 0.1 molar. So you get twice the concentration of OH minus when it's an alkaline earth metal base. Okay. So to calculate then pH, we need to know the H3O plus concentration. So what is the H3O plus concentration of a 3 molar hydrochloric acid solution? And then what is the pH of that? Oops, of the 1 molar. That should say 3 molar. Let's change that. Sorry. 3 molar hydrochloric acid solution. So again, H plus comes completely off. It's the same thing. H3O plus is H plus. So it's a complete dissociation. So if the HCl is 3 molar, then the H plus or H3O plus is also 3 molar because HCl is a strong acid. And so then to calculate the pH, it would be minus the log of 3. So remember, in the other video, we talked about the pH equation is minus the log of the H3O plus. So when we know the H3O plus concentration from the acid's concentration, we just take minus the log of that. And notice we get a pH of negative 0.48. So sometimes the pH can be negative. That's a strong acid, and 3 molar is fairly concentrated. So we come up with a pH of less than 0. You do not want to have that sitting on your skin or get it in your eyes or anything. That's a strong acid. Number 2, what's the OH minus concentration in 0.1 molar barium hydroxide? And then what is the H3O plus in that 0.1 molar barium hydroxide? And then finally, what is the pH of the 0.1 molar barium hydroxide? So barium hydroxide is a strong base. It breaks up to form Ba plus 2 OH minuses. So if it's 0.1 molar barium hydroxide, then the hydroxide is 0.2 molar because you're getting twice as much hydroxide out when those break apart. So the OH minus is 0.2 molar. So now to find the H3O plus, as we learned from the other video, that 1 times 10 to the minus 14th divided by the OH minus will give us the H3O plus. So the H3O plus then is 5 times 10 to the minus 14th. And then to get the pH, that is minus the log of the H3O plus concentration, and the pH of that is 13.3. So that makes sense because BaOH2 is a strong base. So the pH should come out to be a high pH. Okay, so that is calculating the pH of strong acids and bases.